The Palace Theater is an iconic theater, one of the most famous ones in Times Square, and it's just dying to be raised.
The theater is a box with a box built around it, right? So it's like a box within a box. We have to make sure it stays as is while we do all the work around it.
This is straight engineering. This is Isaac Newton sitting on our shoulders, and we can do this. The entire theater from top to bottom goes below grade, below sidewalk level. So we had to sever it horizontally and put a reinforced concrete beam around the entire perimeter so that when the building is lifted, it doesn't know that it was cut away from its foundation. The real interesting part is the work we're doing down below. We were installing these lift caissons to hold the theater up while we excavate below it.
In order to demolish a building, keep the theater intact, you have to find a way to not disturb the structure that is existing while tunneling and boring underneath and removing all the rock and bedrock underneath.
Rock's not necessarily the most friendly material to excavate. When the rock was soft enough to be chopped, we chopped it conventionally with hoe rams. But when it got really hard, we used hydraulic rock splitters, and then we chopped it in smaller pieces and conveyed it right out of our HOV lane here. So when we drill these caissons from up in the cellar level, we drilled them about 35 feet down.
Right.
Caissons are a big part of holding up very large buildings.
We set those lifting posts inside these 36-inch diameter shells.
So a caisson is essentially there's a cased hole drilled. It's like a pipe that's drilled into the ground, and then a drill rig goes inside of it and removes the rock and soil and then creates a rock socket beneath.
So we created a 30-foot hydraulic piston.
Right.
We took the configuration of the caisson, which is basically a steel shell with a beam inside of it, and we created a mechanism where the beam inside of it became the piston to lift the theater 30 feet in the air so that we can lift the entire theater in one hydraulic stroke. In tandem with our work down below. People are working above the theater, removing and cutting and shoring and pouring concrete to create this 30-foot cavity that will accept the theater in its raise.
I mean, it's remarkable to just think about raising the theater.
New York's the first for everything, right? I don't know whether or not anywhere else in the country they would dare do something like this.
Yeah. Or in Times Square for that matter. We don't really focus on something that may fail or that it only has a certain life cycle. We're designing it to be forever. We're putting a substantial amount of concrete and steel in the ground with the idea that this is going to stand the test of time.
This is something that's going to be good for the engineering community, for the construction industry, and I hope it'll demonstrate to all young engineers that there's no limit to what we can do as long as you have the confidence and the knowledge and the spirit to achieve.
You know, when we were like in school in engineering, we never thought we'd have to do something like this.
No, if my professor could see us now, right?
Right.